Hello, sixth graders. When you watched last week's video about integers and adding integers, I promised that we would formally introduce subtraction. Well, that time has come. This is something that's consistent in math. It happens regularly that you learn something. You learned in first grade that 7 minus 2 is 5. You get a little older and you learn to see the same thing from a different angle. The truth of 7 minus 2 equaling 5 is not changing. We just put it into a broader context. This is something you have to be willing to do as you go forward in math. Well, here's the definition. Here's how we're going to think of subtraction. It's very simple to state. To subtract a number, add its opposite. That's it. Now, there are some subtleties to it that we'll explore, but this is where we're going to begin. A minus B is the same as A plus the opposite of B. Now, you might have said here, if I asked you to say this, you might have said A plus negative B, and that's not wrong, but I think it's going to be very helpful for you to think of this minus sign in some cases as meaning the opposite of, because it does. That's what that minus sign means. And again, this idea of broadening our understanding of a symbol we've already seen. A minus B is the same as A plus the opposite of B. To subtract a number, add its opposite. That's it. That's the definition of subtraction. We will be exploring that in this video. And I think it makes sense to bring in a couple of other things as we begin to learn subtraction. You learned from a very young age that subtraction is not commutative. A minus B is not the same as B minus A. But there's a relationship between A minus B and B minus A. They are not the same, but there is a relationship. For now, I've just put a question mark here. Maybe you can try to come up with that on your own until we get to it. What happens when you take A minus B and then add to it B minus A? And of course, what I've done here is reverse the order of the subtraction, right? A minus B here, B minus A here. What happens if you add those two results? That's going to be a question we'll deal with in this video. And finally, you've been introduced to the symbolism for absolute value. These two vertical line segments here stand for absolute value. So I want to also explore the question, what is the absolute value of A minus B? It represents something. Maybe you can also anticipate that. Ladies and gentlemen, next thing I want you to do is to consider this equation. A plus 9 equals 6. A first grader would think you're crazy, would think something's wrong. What number can you add to 9 to get 6? But I bet you know what it is. It's negative 3, isn't it? You already know how to add integers. Isn't it true that negative 3 plus 9 is 6? So that A right there is negative 3. Why am I bringing this up at this point? To make this very important point. I wrote an A there. It didn't have a sign in front of it, didn't have a minus sign in front of it, and yet it's negative. In math, when we write a letter like that, even if there's no minus sign in front of it, it could be a negative number, and here it has to be negative, even though I didn't write a minus sign in front of it. That's very important. Keep that in mind. So now let's see what happens when we consider two situations, one where the number A, we're going to say that it's 3. And then we're going to say that the number A is negative 3. And what I'm going to do in each case is put a minus sign in front of the A. And what I want to do here in these two little examples is emphasize this. The opposite of A. That's what this says. Now, everybody, me included, when we read this, we might say negative A. Read this, negative A. Okay, that's not wrong to do that. But it's very important to realize that it can also be read as the opposite of A. That's what that symbol means. That little symbol that you learned as a first grader. Let's think of some of the things that that symbol means, that little horizontal line segment that's put in front of something. What does it mean? Well, to a first grader, it means take away, right? You've got 7 things and you take away 2 and you're left with 5. Okay, we very early learn the word minus as well. And in our minds as very young people, 7 minus 2 is the same as 7 take away 2. And then we get a little bit older, we're exposed to the idea that there must be numbers to the left of 0, and we see that same symbol and we say, oh, that's a negative sign. It means this -3 means the number that's 3 units to the left of 0. So it's also a negative sign. It's minus or take away, it's negative, but now it is also opposite. It means the opposite of that number. Now think about this for a minute. Over here, we see this thing here, this symbol, the sign and the 3, and we say the opposite of 3. Well, what is the opposite of 3? It's -3. So they're the same thing, okay? Go back here for a moment. If A is 3, what is the opposite of A? Well, A was this. We just put that opposite sign in front of the A, so put the opposite sign in front of this number, right? If A is 3, then the opposite of A is -3, okay? Shouldn't be too surprising. But over here, look what happens. If we are claiming from the start that A itself, that number, that A, is -3, and then we put a minus sign in front of the A, we say the opposite of A, okay? Well, what we have to do is we have to put a minus sign in front of what we're saying the A was. So now there are 2 minus signs in a row, right? If A is -3, the opposite of A is put a minus sign in front of the -3. What do you think that is? Well, let's read it this way. The opposite of -3. That's legitimate to read it that way. What is the opposite of -3? Well, it's 3. So the opposite of A is 3. If A is -3, the opposite of A is 3, because 3 is the opposite of -3. Now, this idea of the 2 minus signs right next to each other in front of a number. Some people like to say, well, they cancel to a positive. Okay, you can think of it that way, but you can also use this idea of opposite. If you want to, you can think of it this way. The opposite of 3. The opposite of the opposite of 3. Now, to me, that gets a little confusing. I think it's easier to think of it as the opposite of -3, which is 3. But if you think of it as the opposite of 3, let's think about that on the number line. So here's 3, right? Here's 3. And we want to take the opposite of 3. Well, the opposite of 3 is -3. That would take us here. And then we've got, so that was this minus sign. Then we've got another minus sign. We want to take the opposite again. So we jump back to get to 3, right? The opposite of 3, start at 3, taking the opposite of it once brings you to -3, but then taking the opposite again brings you back to 3. This is that idea of the 2 minus signs cancel to a positive and leave you with just 3. Or the opposite of -3 is 3. Let's consider 7 minus 2, and then we will consider 7 minus -2. Well, don't be concerned. 7 minus 2 is still going to be 5. But under our new definition, 7 minus 2 is equivalent to 7 plus -2. And if you think about how we add integers, which we explored last week with the vectors, 7 plus -2 is 5. 7 minus 2 is still 5. But here's something that might surprise you. In a similar way, I think a lot of you were surprised one day back in 5th grade when I asked you, what is 12 divided by 1/3? Remember that? 12 divided by 1/3? A lot of you thought it might have been 4 or something else, but of course it turned out to be 36. And when we talked about what it means to divide by a number, we saw that 12 divided by 1/3 had to be 36. It was the only possible result, even if it seemed strange when you first saw it. Well, 7 minus -2 is kind of similar. The result might surprise you, but when we apply the definition, it works out perfectly. What does it mean to subtract a number? Let's see this as the subtraction sign. To subtract a number means to add its opposite. So to do 7 minus -2, what we're going to do is we're going to add something. We're going to add the opposite of -2. Now, remember a couple minutes ago we saw what it means to have two minus signs in front of the number. So what is the opposite of -2? -2. The opposite of -2. Okay, if this is -2, the opposite of that would look like this, right? The opposite of -2. Well, that's 2. +2. The opposite of -2 is +2. So to subtract -2, you add 2. All right? And the answer is 9. This is that answer that I thought might be surprising to you. It might be just like 12 divided by 1/3 being 36. Does this surprise you that 7 minus -2 is 9? Well, we're going to try in this same video to convince you that that is good, that that's the way it should be. But the only thing you have to do to get to the correct answer is the definition. To subtract a number, add its opposite, and the opposite of -2 is 2. So we're going to add 2. 7 plus 2 is 9. Again, some people like to do this. They see the two minus signs in a row. I've actually seen a lot of students over the years do this. They kind of take the minus -2. They think that it's going to cancel to a plus sign. They actually write that plus sign in there. 7 plus 2 is 9. It works. Now, I think before we move on to those other two, 1, 2, 3, I set out the goal for this video, 3 things. We're still kind of on number 1 at this point. I want to do 2 more subtractions before we move on to those other 2 matters. And the other 2 subtractions I want to look at, I think it'd be interesting and educational just to consider, well, what if this first number over here were -7 in front of 7? Instead of 7. It's really not going to change our definition of subtraction. It's not going to change how we approach the problem, but we're just changing that first number from 7 to -7, and otherwise it's the same thing. To subtract a number, add its opposite. So -7 minus 2 is -7 plus the opposite of 2. It's -7 plus -2. Now, at this point, I'm just going to offer an observation through the years. I think one of the big points that students stumble over initially is with something like -7 minus 2. What students don't realize about -7 minus 2 is both of these numbers are negative. Sometimes I say you have to stop thinking like a first grader. By that I mean, don't see this as a 2. It's got a minus sign in front of it. It's really -2. A first grader is not going to think that way. A first grader is going to think it as take away a positive. But we need to see that number as a negative in the sense that this is equivalent to -7 plus -2. So this is -9. Sometimes students want, no matter how it's written. See, we're adding a little bit of complexity here. We're sort of rounding out the symbolic picture, and that's what makes it difficult. When we were looking at just adding last week, Negative 7 plus negative 2. This would have been a red 7 and a red 2, the two left-pointing vectors. Vector that points to the left by 7, another vector that points to the left by 2, and we put the vectors end to end and get negative 9. Well, this is the same thing. The exact same thing. Negative 7 minus 2 is the same as negative 7 plus negative 2. To subtract 2, you add the opposite of 2. To subtract 2, you add negative 2. And this idea that it's negative 2 no matter how you look at it, I think is something you should take to heart. Now, how about this one? Negative 7 minus negative 2. To subtract negative 2, add the opposite of negative 2. So this one becomes negative 7 plus 2, because the opposite of negative 2 is 2. To subtract negative 2, you add positive 2. Positive 2 being the opposite of the negative 2 up here. Negative 7 plus 2 is, of course, negative 5. Either way it's written, the answer is negative 5. All right, so there are 4 subtractions for you, and this pretty much covers the whole gamut. They can't really be any different than these 4. Always keep in mind the definition. We're now going to go back and look at this number 2 that I put here. And let me ask you now, did any of you realize that I had that question mark there? What needs to go there is 0. When you take a minus b and then add to it b minus a, you get 0. Let's explore that a bit. I put the a minus b and the b minus a in parentheses to kind of emphasize what we're doing. We're doing a subtraction, then we're reversing the order of the subtraction. But sometimes parentheses indicate multiplication, but they don't here. There's an addition sign between the two parentheses. So the parentheses really don't mean anything. We've got a minus b plus b minus a. Now take a look at these 4 numbers that are being added. I can say that because subtracting b is the same as adding negative b. I could put a plus sign in here, and I could put a plus sign here. B minus a is the same as b plus negative a. Well, these 4 numbers that are being added together, 2 by 2, they add to 0, right? Look at these 2. Negative b plus b, that's 2 opposites. These numbers are opposites of each other. There's a b and there's a b with a minus sign in front of it. The opposite of b plus b is 0. When you add 2 opposites, you get 0. And the other 2 numbers are a and negative a. We can just see it as a minus a, it's 0, or we can see it as a plus the opposite of a, right? This is the opposite of a, and we could think of a little plus sign being there. So there we get 0. And that's why when you have a minus b and you add it to b minus a, you get 0. So what does that allow us to say? A minus b and b minus a are blanks, beginning with an O. The answer is opposites. You see, so subtraction is not commutative, but when we change the order of a subtraction, we don't get some random answer, we get the opposite of the other answer. And we'll look at a few examples of that right now. I've said to 5th and 6th graders for many years now that I think there's something in a young human brain that is sort of wired for negative numbers in a sense. As soon as a young person, before they ever come to me as a 5th grader, as soon as a young person is introduced to the idea that there are these negatives numbers, I think that person kind of figures out on his or her own that 2 minus 7 is negative 5. You might have had that same experience. I know many, many students through the years have had that experience. I don't really have to teach 5th graders that 2 minus 7 is negative 5. They figure it out on their own. Well, look what we did here. We flip-flopped the 2 numbers around the minus sign. We changed the order of the subtraction, and we got an answer that was the opposite. 7 minus 2 is 5, and 2 minus 7 is negative 5. This is my point. When you change the order of a subtraction, you get an answer that is the opposite of the other one, no matter which way you go. If you start here, switch the order, these two answers are the opposite of each other. By the way, we're looking at the same 4 subtractions we did earlier, and we already know, we saw how to get to the answers to them. Now we're going to change the order of the subtraction. I drew a red arrow here to this sign because we're going to think of that as the subtraction sign. Over here, it really wasn't necessary. There was just one of those signs. This is the subtraction sign. It's 7 minus -2. What we're going to do is change the order of the subtraction. We're going to flip-flop the 7 and the -2 across over the subtraction sign. Okay? We already know that 7 minus -2 is 9 because 7 minus -2 is equivalent to 7 plus the opposite of -2, which is 2. So this original one here is equivalent to 7 plus 2, or 9. What happens if we put the -2 on the left and the 7 on the right of that subtraction sign? -2 minus 7. Well, that was like another one. I think that one was down here. This is very similar. This is equivalent to -2 plus -7. This is -9. Notice that what happened. We got the opposite of the other answer. And earlier we had this, -7 minus 2. And that's why I say, you know, when we did the flip-flop around the subtraction sign, we did get something the same as this, right? -2 minus 7, -7 minus 2, those are the same result. This is equivalent to -2 plus -7, which is -9. This is -7 plus -2. Addition's commutative. But let's take this subtraction. We're going to see this sign here as a subtraction. Okay? That's the subtraction sign. On one side, we've got -7. On the other side, we've got 2. We're going to flip-flop, reverse the position of those numbers across over the subtraction sign. And we're going to get this, 2 minus -7. Now this minus sign here, that is the subtraction sign. Get the subtraction sign here, there it is again. We've reversed the position of the two numbers across the subtraction sign. So the 2 came over here to the left, and the -7 came over to the right. So now we have 2 minus -7. That is equivalent to 2 plus 7. To subtract -7, add 7. So this becomes 2 plus 7, or 9. And the point is that, notice once again, the two answers were opposites of each other. First way was -9. When we changed the order of the subtraction, we got +9. And the last one, earlier, we had this. We had -7 minus -2. This time, we're going to see this minus sign here as the subtraction sign. -7 minus -2. This is the subtraction sign. Okay. Now, when we did this one earlier, we saw that it was equivalent to -7 plus 2. To subtract -2, add the opposite of -2. To subtract -2, add 2. So this was -7 plus 2, which was -5. Now let's flip-flop the numbers over the subtraction sign. This is still the subtraction sign in that position right there, right? There's the subtraction sign. And I have flip-flopped the two numbers across the subtraction sign. I put the -2 on the left and the -7 on the right. Now we interpret this to mean -7 plus 7. To subtract -7, you add the opposite of -7, you add 7. So this becomes -2 plus 7, and -2 plus 7 is 5, right? -2 minus -7 is -2 plus 7, and that is 5. And that 5 is the opposite of -5. The point here is, no matter what two numbers you are subtracting, if you reverse the order of the subtraction, you get the opposite of the other answer. slight change of plans here. I noticed that we're up to 25 minutes. I think it's best to address this third item in another video. Replay this one as often as necessary until you get it, until you understand it completely. It's very important that you do that. Practice also will be important. When I ask you to practice some of these subtractions and you consistently get the correct answer, then you can be pretty sure that you understood everything that was in the video pretty well. But use it as you need to use it. Right? And again, we're going to come back to this number 3 here, the absolute value of A minus B, in another video. So long for now.